right. So I think I can see the count is almost 70 plus. So all of you are champion with the digital, right? I am assuming. And in terms of language, it's only English or mix or Hindi. Any preference? Anyone? Else I
Only
will do.
English,
Mixed,
sir.
sir. Mixed.
Only English.
Okay. Only English and mix. Okay. We'll have 80% in the English then. No problem. Chali, all right. So if it's about Verilog, so I believe you are already done with the digital and you are champion in the digital now. So let me ask one simple question from digital, and then we'll go ahead with the Verilog. Like what is the necessity and how we'll go with the Verilog? What's the our table of content and those things we'll see. Basically, the roadmap we'll see. Okay, so in the digital, let me ask one simple question. Okay, so let's say this is the circuit diagram. This is the circuit. Okay, and one device it's there. So you need to design this circuit. You need to design this circuit so that if I'm giving inputs X and I'm getting output Y, so it should be such that Y should be such that 128X plus 128X. So you should get 128X plus. Just a second. So this is the first question. So can you quickly drive this? Can you quickly drive the circuit for this circuit? Okay, in this, what should I mention? X is of 3-bit input. Okay, and Y is output. So we will not talk about the size of Y. So you need to just design a circuit to achieve this. Can you quickly try? Can you try this immediately? Basically, I just gave you the relation between input and outputs, and I want the circuit, how to get this circuit in the digital.
Sir, we may use AND gate in it, and one input would be X and another input would be 128.
Can you give me at least an idea, like how many gates you required? You can give tentative range also, like 10 to 20, or some complexity, some information you can give.
8 bits.
Sir, we can simply 7 times left shift the input X.
No response? Or let me just reduce the question. You can just take a smaller value. Let's say y equal to 16x plus 4. Let's say this value. Anyone? So don't, if you're thinking like it's a complex or it's a time-taking question, so answer is no. If you are thinking like preparing truth table, input-output combinations, K-map, so story is not like that. Anyone?
Here we need a multiplier and adder that can multiply.
Multiplier and adder, but that multiplier and adder is the part of circuit, right? And for that only I am asking.
For adder, we have to use XOR gate. Okay.
Adder you can use XOR gate, but one XOR gate is only for 1 bit, right? I think you are aware.
Yes, yes.
But here you can see X is of 3-bit wide, and 16 and 4 itself is not a 1-bit wide number. So which is in the decimal. So these are in the decimal. Decimal. So for example, if I give X equal to 2, okay, in decimal, so what is Y I am expecting? I'm expecting like it should be 16 into 2 plus 4, that is 32 plus 4, that is 36. So 36 in decimal I want, and you can convert this in the binary also, 0 0 1 0, and this 36 also you can convert. You can convert in the binary.
Okay,
So
we
if
need
you, Hanji,
we need
what you're saying?
encoder that will convert. It will take the input as binary and will convert into decimal number to encoder circuit of different.
Try to understand, converting from decimal to binary is not a part of this circuit, right? This circuit is not a binary to decimal or decimal to binary converter. Correct?
Sir, your voice not coming, sir.
No, others can hear me, right? Others can hear me? Hello?
Yes, sir.
Yes, sir.
Others can hear me.
Yes, sir.
Hello? Yes. Chali, last chance. So anyone have an input on this? So how to achieve this? Can someone tell me? How to achieve this question? How to achieve circuit for this? So do you need multiplier or something like that, or how?
Might be like more input gates, like 16 input AND gate and an OR gate.
No.
Sir, one multiplier
See,
and one adder.
AND gate is not a multiplier. तो ये तो बहुत बड़ी mistake है. If you are thinking 16-bit AND gate is not a multiplier. OR gate is not a adder. OR gate adder है, तो XOR क्या है? XOR gate is also not a adder. XOR gate अगर adder है, तो half adder क्या है? Half adder is a circuit, right? So AND is not a multiplier. AND gate is not a multiplier. OR gate is not a adder. So then what else? So try to understand. If I will change this question.
Shifting X left by 4 bits.
Yeah. So now she is giving absolutely correct answer. Almost okay. So, but whatever she think like that's absolutely correct. Actually, this question is base specific. If you think here base is binary, let's say base 2, that means radix 2. So if you want y equal to 2x, okay, and let's say if I am asking base equal to 10, and if I am asking y equal to 10x, so you know what you have to do. Whatever x is there, let's say if x is 60, so what will be the y? So y will become 600. Okay, and if y equal to x by 10, so what it will become? X will become 6. Similarly, if you have 70, or let's say if you have 10, so this will become first one will become 100, and this will become 1. And similarly, if you are in the binary, so what is this 2x? So if you have, let's say, x equal to 1, if x equal to 1 you are taking, and you are doing y equal to 2x, and you are doing y equal to x by 2, so what it will become? Or let's say, because it's a 1 bit, so we are not taking this division part as of now, because we need to increase the bit. Okay, or let me take this as a 2-bit wide. 2-bit wide, 2-bit wide is fine, right? So let me take this x equal to 1 0, then y equal to x by 2. So now what happened? 2x will become 100, and x by 2 will become 10. So which means this is equivalent to, this is 2, and this is equivalent to, this is 4, and this is equivalent to sorry, this will become 1 only, not 10. So this will become 1. So what you observe here, what actually you observe here, and if you'll change the number, then also you will identify same thing. So try to understand here, if you are multiplying a number by its base, or if you are dividing a number by its base, it's nothing but shift. लेकिन उसी base में, in the same base. So here you can see the base is, the radix is 2. I wrote the number 10, and 2x means multiply by the same. So which means I just shifted, and here I just shifted toward right. So this will become 0 1, this will become 0 6, this will become 0 1. You understood? And let's say if you want this question, so what can we do? You just need to simply think, you just need to break down this. You just need to break down this. Y equal to, when you have 16x plus 4. So first forget about this plus 4, first think about the 16x. So this is nothing but 2 of 2x and 2x and 2x. You understood? So what's this? This is nothing but 1 time shift, 1 time more shift, 1 time more shift, 1 time more shift. In total, this is nothing but 4 shift. Agree? No response?
Yes, sir.
Yeah. And when you are doing shifting, so definitely those pending 4 bits or 4 digit will be 0 for sure. So what you can do? You can add a fixed number, or let's simply say you can replace them. So let's say if you want plus 4, so what you can do, instead of saying addition, you can replace them. You can replace this as a 1. So finally, what will be our circuit here? What will be our circuit here? In this case, if you'll see, this is nothing but, just a second. Yeah. So if I will cover this circuit, okay. So how simple is this? Just see. So you have x, and when I say 3, it could be 3, it could be 4, not an issue. X. So this is x naught, x1, x2, x3. And output will be y7, y6, y5, y4, y3, y2, y1. Clear? Hai? And y naught. So what you need to do, simply you need to connect these. You need to connect these 4 like this, which means they will be already shifted. which means you shifted. And what about remaining one? So for the remaining one, you can hard code. You can just hard code this value. You can hard code this value to 1. You can hard code this value to 1. So finally, what you will get here? 0, 1, 0, 0, and x0, x1, x2, and x3. So you will get the shifted version, which is nothing but 128. Sorry, kya number tha? 16 of x, and this is nothing but +4. Every time you hard code it. Agree? Anyone have any doubt in this? No response?
No, sir.
Clear hai? No response?
Hello.
Yes. Yes.
Yeah. From Y3, Y2, Y1, Y0, how to get 0, 1, 00, sir? Could you repeat again?
Because this is you can connect it to the power supply, na VCC, and you can connect it them to the ground.
Yeah. So, okay.
That means no additional
Like,
circuit is
yeah.
no additional
Yeah.
gate is required.
Yeah. Like TILO cells are high-low cells, right? From Y3, Y2, and right?
Correct. So
Understood.
this is basically hard coded. Understood?
Understood, sir. Thank you so much.
Okay. So what about others?
Sir,
How will it be +4?
+4 because see, just a second. Yes. So +4, try to understand. Let's say I am saying you have a number which is x, which is simply x, and you need to do 100x. 100x plus 4. 100x plus 4. So what you can do when you are doing 100x, so definitely they will be x will be shifted. Okay, let's say example is 64. So this number will become 64 and dot, and these space will replace with 0. Agree? So this is nothing but your 100x. But what I am saying, instead of replacing these blank space with 0, if you will replace these space with 0, 1, so this will become 100x plus 1. Agree? And if you will do 64 and blank space, if you will replace with, let's say 4, 0, 4, so this will become 100x plus 4. And here this is nothing but 100x plus 0. So basically what you are doing here, you are doing shifting plus 0 padding. Okay, but in this what you are doing, shifting plus your padding, or you are replacing those zeros with 1. So which is equivalent to you are adding a 1, and here you are adding like +4. If you will go to the binary, then what you are doing, shifting means, let's say the x number is 10. Okay, or let's say 000010. So this number will shift 0010, and you have 4 space. So if you will just simply write here 0000, so this will become 16x plus 0. But if you will change and if you write 0010, and then this replacement you will do with 0010, so this will become 16x plus 2. And if you will do 0010 and 0100, so this will become 16x plus 4. So because every time we are replacing these 40 with 0100. You understood? So you can see what is the difference in this first one and the third one. So first one is this number 0010 and 0000. And the third one you can break down is 0010 0000. And later you can write 0000 0100. So here you can say this number is nothing but 16x and this number is nothing but 4 in the decimal, and this whole number which is this, it will become this whole number will become 16x plus 4. At least now clear? And here this is 16x. Clear? Eh? If you'll do addition. Clear? Eh? No response?
Sir,
You following the 8421 code, right?
Yes. Yeah. 8421, correct. Anyone have any doubt?
sir, isn't it like a continuous sequence of the 16x or it's separate?
It's a 16x plus 4, na? Whatever, see, this 0, whatever you will make a hard code, it will become 16x plus that number. If you will do, if you will hard code like 0110, then this will become 16x plus 6.
Got that conversion of 4 to 6, but didn't getting like how, where did the addition happen?
Addition is happening when you replaced. Try to understand. Here I explain, na? See, whenever 0 are replaced with 0100, it seems, try to understand overall results is like that, like they added. The behavior is such that. You understood? We see, why are you getting confused? Because we are not making two numbers addition. Actually, what we are doing, we are just replacing the bit.
Okay, then that
Try to
means when
uh,
it get replaced, at that time the addition is actually seems to be happen.
correct.
Okay.
This is the same what I was explaining. So it seems to be we hard coded this 4 and we are bypassing that hard code value. We are bypassing. So overall result, it looks like the number is getting added. Clear? Eh? So it looks like number is getting add, but actually we are replacing those 0 with that number.
Every binary bit shifted to the from left to least shifting it bit to right shift, right?
Exactly. And when this circuit will fail, so this circuit will fail if you want 16 x plus, if you want 16, then this will become fail. Why? Because this 16 you cannot put here.
We
Getting
can't
my
reach.
point? Because maximum we can put is 1111. So that's why I'm saying it's not a actual addition. We are hard codedly replacing, and the overall results, it looks like a addition. Clear? Eh? So it's all about how you are perfect or how you are used to the design. So shall we go ahead now? Okay, so you can note down a question for your homework if you are interested. And the simple question is, I will give another question which is similar and one different question. You can try like y equal to 32x plus 8. This you can try. Okay, and you can do y equal to 64x plus some 16, such that you can try. But I'm not interested in this question. I'm interested in this question number 1 or question number 2. I'm interested in this question number 2. So question number 2 is nothing but y equal to, let's say, some number which is not in multiple of that 2. So which is, let's say, 38x plus 2, 38x plus 4. I'm interested in this. Don't think in such way like I need a 38-bit AND gate, one XOR gate. Don't think like that. Apply same approach if you can. Okay, and one more question. I will not explain, but I can give you as a homework. So I think you are done with the counters also. So one counter question I want to give you: 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 5. Yeah, and again it will restart. Again it will restart. So how many? The question is not to design this. Actually designing bhi आप कर सकते हैं, but I am interested is how many minimum कहिए या required कहिए. I want both answer. Required flip flop to design this counter. Okay, can anyone blindly tell me the answer for this just immediately now? Else you can try in the homework, and we'll start now that Verilog for which we are here.
Sir, 4 flip-flops are required, sir.
Okay, so those who are saying the answer, so now I want like they should come up with the circuit. Okay, so one guy said like 4 flip-flop. So I want like with the 4 flip-flop how you will do. Okay, so I want that. Clear hai?
Sir, can you
Chaliye.
scroll up?
Yes. Now we'll start that Verilog. Yeah, anyone have any doubt? Last chance, you can ask.
Sir, what is this topic is called?
This topic, actually this is not a dedicated topic. I just gave a random question because I thought like before Verilog, because in the Verilog I will use that digital also. So one two question I thought like we should put initially. Okay, so just I blindly put. This second topic is from counters designing, and the first one is circuit basically. So
Sir,
arithmetic. This
can
is
you show
arithmetic
the circuit?
for this counter.
No, sir, for the 16x plus 4
Okay.
expression.
Yeah, you can see. Okay, so now we'll start that Verilog. If anyone have any doubt from this, you can ask. Can we go ahead?
Yes, sir.
Okay, fine. Okay, now anyone have any idea about Verilog? Why it is required, or what are the things we'll cover in this Verilog? From where it came? What's the history? Anyone have any input on this?
It is required for the to write a code for the design circuit.
Basically, it is a hardware description language where we like write codes to describe the hardware.
Okay.
Verilog
Others?
is
Describing a hardware in
logical
a
connection.
language.
It uses it to model and design the circuits.
It is a logical connector to sequential circuits or standard cells.
Okay. So all of you are giving almost correct answer, which is good. Okay. So let me put. Verilog is only used for designing purpose. Okay, you are also correct. So let me put in a proper way. If you don't have any idea, then also you will get the idea in upcoming few minutes. So try to understand. We are in electronics domain. Okay, ECE. And when it comes to ECE, so if you will see any mechanic or any illiterate which is not a engineer or maybe a scientist, something like that, a guy, so they cannot create a electronic gadget, but they can make or they can create a mechanical gadget. For example, a toy, a vehicle. तो कोई भी छोटा कार या ऐसा कुछ है, you can see a normal person can prepare by in home or something like that. But when it comes to electronic, I think it's not as simple. If you'll see in the village, so the kids, they are having their own toy. They're preparing, they're making with some mechanical things like spring and some wheel or something like that. But anyone saw with any chips or any mechanical gadgets? The reason is, whatever we have in the electronics, the main thing is there is a barrier. Whatever we have from the nature and whatever is required in the gadget, there is a barrier. But in the mechanical, whatever it's there from nature, directly you can see in the mechanical gadgets. For example, counter. For example, counter. Let me take an example of a counter. So mechanical counter and electronic counter. So in the mechanical counter, you can see you can have some sticks, a bundle of sticks, and you can place one by one stick from let's say you have 100 of sticks. You are putting one by one like that, one here, one here, one here. At last, you can count the remaining sticks. If the remaining sticks is 20, so the count value is 80. And then you can merge them, and from the next day you can follow same strategy. Like that you can count. Or you can see some manual counters are there. If you visited sometimes a big bazaar or something, you can see there. But when it comes to electronics, okay, so what is the special thing required? Or what are the missing things in the mechanical counter? Why we are moving towards electronics? So if you'll see, if I will ask you, can you tell me the counter for a day before yesterday? So if you note down somewhere, then only you can tell, else you cannot tell me. So basically what I want to convey here, one is missing thing is that memory. Memory is not there in the mechanical counter. And many more features. That storage, that battery and those things. But with this electronic gadget, you can tell even last year data also. If money is not concerned. Money is not concerned means because memory is costly. If you see the mobile phone, if you are increasing the storage, the cost is rapidly increasing. Because memory is nothing but gate is nothing but flip-flops, is nothing but registers, is nothing but a memory. So the thing is, electronics is having something, let's say this memory. And memory is not available from the nature. Human के अंदर तो है memory, but a device or something like that, I think no. So let's say iron. So iron is not having a memory. Gold. तो जो भी हमें nature से मिली हुई चीजें हैं, sand, they don't have any memory or some provision like that. So that's why electron is a special branch. Okay, and I will start from here only. I will start from here only. So let me just tell you 1 second. How to add one? Oh, sorry. Sorry, guys. Just a second. New page. Okay. Yeah. So now try to understand. Now try to understand. You have some requirement. You have some requirement. Now requirement could be that counter itself, or it could be anything. So what you want a processor or you can say chipset. So हर एक requirement के लिए electronics is nothing but that circuit. Okay, so that circuit, and this circuit is nothing but that compact form, which is nothing but a processor or IC, you can say. Okay, IC or processor. So which is nothing but, when I said this circuit, so this circuit could be a IC also. तो ये भी एक IC हो सकता है. क्लियर है ना? और हमारी रिक्वायरमेंट क्या थी? दिस इज द रिक्वायरमेंट एंड दिस इज द फाइनल. This is the final IC. So that's why I put one question from the digital, so that I can go in that approach. Okay, so you can relate with me. So this is the IC. Now try to understand. Requirement could be anything. Requirement could be anything. Requirement could be like whenever I am giving a print, so I should get print. Whenever I am pressing a button, light should on, or sensor could be there. Whenever it's a motion, so motion detector should detect the motion, and some action should happen. Basically what I am saying is, there is a requirement, means the relation between input and output, and that should be available in the form of IC. Clear? I think yes. Now let's start. How to achieve this? How to achieve this? So requirement, what you can do, requirement you can convert in the form of a digital circuit, as we just saw. Clear, sir? I think yes. Up to here it's clear. Now what you have in your hand, you have a digital circuit in your hand, and digital circuit means which contains number of gates, lots of gates. Okay, it could be anything but lots of gate, and basically lots of input and output. Clear? So this digital circuit is available physically? Answer is no. So this is available only on the paper, and you need to fabricate a IC, a physical processor. So where is the gap? The gap is you need to fabricate that. So if you have circuits, if you will zoom in this, so this gate is nothing but this is made up of some MOS. Okay, some MOSFET or something like that. It's like that. And if you will still zoom in this, so this is nothing but a combinations of many things, but these things are directly available from nature. These things are directly available from nature. So first of all, you should get that that MOSFET from nature with some mechanism. Then you should make some connections like that, and then you should make connections like that, and then according to your design, you should make connections like that. Then only you will get a IC. And don't worry if you already know these things, so don't need to get bored. Okay, we'll see lots of things, but this is for those guys who some of you maybe don't have any idea. Okay, So don't judge on today's session. Have patience. Okay, I think you can understand. So basically what I want to convey is जो हमें नेचर से अवेलेबल था वहां से हमने एक स्टेप आगे बढ़ा, मॉसफेट से एक स्टेप आगे बना हमने गेट्स, एक स्टेप आगे बना कॉम्बिनेशंस ऑफ गेट्स, एंड यहाँ से हम फैब्रिकेट करके एक आईसी दैट मींस जो हमारी रिक्वायरमेंट थी उसको पूरे करने का ट्राई करते हैं. नाउ ट्राई टू अंडरस्टैंड हियर, ट्राई टू अंडरस्टैंड what are the challenges here. What are the challenge you may expect here? So basically two types of challenge are there, two challenge, first one and the second one. For example, your requirement is z equal to x plus y, and z equal to x plus y if you are doing, so if you are giving x and y, let's say x equal to 4 and y equal to 5, so what you are expecting at z, you are expecting 9. But let's say instead of 9 you are getting 12 or you are getting 0. So immediately what you will think, or or what's the conclusion here? The conclusion is this IC or processor is not working properly. Agree? No response, guys? No response? It's not working properly. So now two reasons are there. Either your circuit is functionally fail. So functionally fail. That means whatever functionality you selected, that functionality itself is wrong. मतलब आपका सर्किट ही गलत है. And second one might be when you fabricated this IC, so you may get some fabrication fault. That means fabrication failure. And fabrication में क्या क्या इशू हो सकते हैं? पावर फ्लक्चुएशन हो सकता है आपका, सो पावर फ्लक्चुएट किया हो, या डस्ट पार्टिकल आ गया हो. डस्ट पार्टिकल आ गया प्रोसेसर में तो कैसे काम करेगा? देयर इज नो कनेक्शन, राइट? सो डस्ट पार्टिकल्स आपका आ सकता है, या डिस्टरबेंस हो सकते हैं, मोशंस हो सकते हैं, डिस्टरबेंस हो सकते हैं, मोशन हो सकते हैं. You understood? So but basically two types of challenge we have. One is that functional and another one is that fabrication. So fabrication में जो failure हैं, we cannot avoid them 100%. We can't say like they will never occur. We can't say. But what about functional? Anyone have any input? Functionality, because functionality is not like dust particle or something. So functionality should be 100% correct. Even not 99.99. It should be 100% correct. Agree? No response, guys?
Agreed.
Yes. Huh. So I will just remove the second part. Although it's important, second part is important, and we have lots of provision to reduce. But second one को हम reduce ही कर सकते हैं, zero नहीं कर सकते sir. So I will talk about, I'm interested in this first part, which is functionality. Sir, functionality तो कम से कम आप 100% correct रखिए. आपकी functionality ही गलत है, so how can you expect a processor to sell or something? If you are purchasing a laptop or mobile, are you expecting कि उसका processor की functionality ही गलत है? Answer is no. So now one challenge we saw. Now what is the resolution for that? So resolution is very simple. What we can do, whenever we have our circuit and before fabricating this, that means pre-silicon, what we can do, we can verify the functionality. Agree or not? No response? We can verify the functionality. Then what happen? If it is 100% functionality correct, then you can go to the fabrication. Now, how you will verify? How you will verify?
Verilog.
So, Verilog आएंगे. Verilog तो बहुत दूर की बात है. So, how you will verify? So, human
manual or
can do verify with some reference. With some reference. Right. Let's say you need to do z equal to x plus y. And I am saying x equal to 5 and y equal to 4. So immediately you are saying z equal to 9. So when you said z equal to 9, you have a brain as a reference. यहाँ पर आप brain को reference लेके चल रहे हैं और आप कह रहे हैं कि correct है या incorrect है. But if I will put a complex circuit here, let's say z equal to x of e to the power y, then immediately you will fail. And let's say I am giving x equal to some value, let's say 99,99999 and y equal to 88888. Now I'm asking is what is z? Z equal to 1112222. So can you verify? Answer is no. So what you can do? You can have a already verified design. That means आपका reference error free होना चाहिए. You may have a error free another design. Clear है? You may have error free design. But what's the main concern here, or what I want to convey? I think someone already said. So what we can do, we can manually verify. We can manually verify, which is correct. Which is correct. And now you can send it to the fabrication. But what happens? You know, human have a very good brain, okay, and no doubt on the capability, but still, in terms of time taking or in terms of complexity, it has some limitations. वो एक साथ काम नहीं कर सकता, बहुत कॉम्प्लेक्स नहीं कर सकता, और इसी के लिए कंप्यूटर्स आया था, राइट? So computer is nothing but that it can do whatever human brain can do, but very fast. Just a second. Sorry. So manually, that means what I want to convey here. Let's assume if Intel processor. Okay. So manually it is not possible to verify. So which means we need to replace this manual verification with the computer. So computer will come into picture. For what purpose? For verification. So if you will not verify, then what happen? Then you may get the failure, the functional failure. And for verification, if you will do manual verification, then most of the time it is not possible. It is beyond the capability. Human brain की capability के ही परे है. Okay. So what's the alternative approach we can have? We can go with the computer. So computer can do faster. Computer can verify. You understood? I think yes. But if I will replace this verification or this verify functionality, if I will replace this with the computer, let's say I just replace this with the computer. Now, what is the issue? Do we have some issue? Answer is yes. The problem is there is a barrier. There is barrier. The barrier is this is the circuit. This is the circuit which we have on pen and paper. Basically, this is a diagram. Basically, this is a diagram. और कंप्यूटर के लिए तो ड्राइंग है सर, ये तो पेंट है. कंप्यूटर के लिए पेंटिंग है. And computer can understand only programming language which is 10. Computer can understand only 10, or basically program, some program. Now there is a barrier. Whatever you have as a circuit, that is meaningless for the computer. And whatever computer know, which is nothing but an instruction. Set of instruction is nothing but a program. A program. So computer can understand program, but you have circuit as a drawing. So to overcome that barrier, what you have to do, you have to make a equivalence. Equivalence means what you need to do. You need to make some equivalence for this diagram or for this circuit in the form of program. That means you need to describe your design और डिजाइन भी कौन सा हार्डवेयर वाला in the form of program. So you need to describe your design in the form of a programming language. In short, what I can say, you need to describe your hardware should be described in form of a language that is nothing but HDL, you can say. So HDL is a short form of hardware description language. So ऐसी language जो hardware को ही describe करे, that is nothing but a HDL. And one of this HDL is nothing but a Verilog. So what is a Verilog? Verilog is a language which is used to describe a hardware in the form of a language, in the form of program. And why it is required? Because you need to verify. Why you need to verify? Verify नहीं करेंगे तो वो fail हो जाएगा. Got it? And why this conversion or equivalence is required? Because computer cannot understand diagram or paint. और ये तो उसको नहीं पता नोट गेट है एंड गेट है क्या है. It's like that. So now what happens? Hey, after this you understood. We need to learn this Verilog. So let's say if you will be the VLSI engineer, so you will do the verification, or you will do the verification, right? So you should know the Verilog. Now what is next? What we will learn in this Verilog? So first try to understand this Verilog is nothing but a equivalence. मतलब ये सिर्फ हमको समझना है कि किसका equivalent कैसे करते हैं. So one candidate defined this, and now we need to understand. For example, what is this? This is AND gate. You know this because you know the symbol. Lekin how computer will understand? So you need to understand one by one, like what is the equivalence for this in a programming language. So that is nothing but A and D. That is nothing but A and D. For example, for this, you should know OR. Okay, sir. You mean बस उसको English में लिख दो तो programming language हो क्या? Answer is no. If you will write A and D, that will not work. If you will write OR, that will not work. Why? Because जो Verilog के developer थे, उन्होंने इसी को follow किया. How should we know, sir, क्या follow किया, क्या नहीं किया? For that only we have some library. Library, what is library? Library is nothing but that collection of these every conversion. And this library or the collection of library is nothing but a software. So that's why if you will go with Verilog, you should know the software also. कौन सा software? जिसमें ये Verilog की library हो. क्यों? Why? Because that software should aware of both the conversions or the meaning of those things. I think you understood now. So now what we covered as of now, we just understand why this Verilog is required and what, not what we learn, or which type of things we'll learn in this Verilog and why it is important. So anyone have any doubt up to here, you can ask. Then we'll go one step ahead. Anyone have any doubt, you can ask.
Sir, could you repeat again? Library means?
See, library means, try to understand. You have your notepad, you have Zoom, and you have WhatsApp in your laptop, and you have Paint, you have Adobe Reader. So if you will write a small A and D, in those software, so that software will understand what is the meaning of this A and D. They will understand this and from English grammar, or they will understand like this is a AND gate? Tell me. So that app will understand this is a simple AND. Okay. So why? Because those software don't have library. Library is nothing but the definitions. The definitions. Whatever developer developed, the definition is nothing but a library. So those libraries should be available. Okay. So that's why we have a software. Let's say Vivado and modeling, model sim. So if you'll talk about a model sim or that Questa sim, okay, so they have a library, and library is nothing but the containing those rules, the definitions. They know the meaning of they know is not the appropriate word. Library contain the meaning of that and. So while you will write the and, so that will come to know like it's a equivalent of a AND gate. They know the mux, case, if, else, and those things. Clear? Hai?
Yes, actually.
Anyone have any doubt?
No, sir.
No response? Okay, so shall we go ahead? I will talk about the list of things which we'll cover in the Verilog. If anyone have any doubt, you can ask.
Library calling like vendor.
No, library is whatever you are saying. It's just nothing but a. These are files only which have the definition. Which have the definition. They have the syntax. Okay, so don't worry about those things because those are tool or software specific. Okay, yeah. Chali, all right. So now in the Verilog, we'll see, because it's a programming language, so we need to understand the keywords. We need to understand the keywords. Okay, and after that, main thing we will understand is data type. Data type. And I will talk about what is actually a data type and what type of data type we have. So we'll talk about that. Then later on, we'll talk about some operators. Operators. So operators means you should know if some operations is happening in the circuit. So how you will write a equivalent code for that. Okay. Then after that, we'll see type of modeling. Type of modeling. What is this? Basically, if you are just making some design in Verilog for a digital circuit. So different type of modeling we have. Different types of modeling we have. So you can opt to any of one, but you should know all. Now, how to decide which one you should opt to? So it depends, or it's based upon the requirement. Okay, so it's depend upon that. So now let me talk about one by one. So first thing we'll cover is data type. First thing we'll cover about data type, and in the data type we'll see wire and we'll see reg. Now Number two, we'll see operators, as I mentioned. Okay. And in the operators, we'll see logical, then bitwise, then reduction and shift, equality, okay, and relational, okay, and some other operators which are concatenation and those things we'll see later. So concatenation is important. Concatenation. And the main important thing is the third one is process. So process is in which sense? Process is in a runtime sense. So that means whenever a process will start, which means runtime start, or you can say in another words, if a process starts, or you can say runtime process will start at zero runtime. You can say like that also. Okay, so we have two types of process. We have a continuous and we have a procedural. Okay, and procedural have two process. One is initial, another one is always. Okay, we'll see in detail. This is just about a roadmap. Okay, and after that we'll see task and functions. Task and functions we'll see. Okay, and then at fifth we'll see inbuilt, you can say inbuilt or system task. System task and functions. System task and functions. And last one is sixth one is we'll see compiler directive. Compiler directives. Okay, and finally we'll see examples. Examples you can say or Verilog project. So we'll see actually lots of example like multiplexer, priority encoder, ALU, these things, and counters also. But if time allow and if you'll be interested, we'll see some good example or good projects, such as we'll do that FSM, okay, and we'll do vending machine. We'll do vending machine or FSM, and you can say counter also here only. Okay, so this I am planning. And advanced project also we have, which is a router. So as of now, we'll not target this, but if time allow, I will give you a little idea. So which is a router 1x3. So this modeling only design. Okay, so like that we'll go. So this is the target, or this is the agenda which will follow in the Verilog. So when we'll complete this, we'll say our Verilog is completed, and you will be a good designer. You will be a designer. You can design. Okay, so let me start with the data type, and then we'll go with task and functions, and then operator. Okay, and before data type, let me give you one idea how it looks like, or how we will design a equivalent thing. Let me take a very small example of mux or something, or adder, and I will show you in a EDA so that you will get some idea. Okay, so that you will get that idea. Chaliye, let's see. So try to understand. You have a digital. This is nothing but I am giving you one idea how modeling will do, how designing we will do. So let's say you have a mux. Let's say you have a mux, which is I1, I0, I1, and this is Y, and this is S. Okay. So your output is nothing but Y equal to S bar I0 plus S I1. So this is nothing but your digital circuit. Now you want the equivalent. Now you want the equivalent in the Verilog. So when I mentioned the keyword, you should know. So keyword I will explain and you will understand. But as of now, you just try to understand how equivalent I am putting. Okay, how equivalence I am putting. So for this block, for this one block or this top block, we'll take one keyword which is a module or end module. Module and end module. Now next thing is about these inputs and outputs. So whatever inputs and outputs we have, and same this module have some name also. Let's say this mux. So you can give module name also. This has a mux or anything like mux, mux name, or mux underscore 2, like 2:1 mux 2 cross 1. You can give any name. Now if it's about port, so you need to tell, as you are telling to this box, like these are the inputs and these are the outputs. Similarly, you need to mention here input of I0, I1, comma S, and output of Y, output of Y. So what is this? Up to here, what we completed? We just completed here. You can see this is the box which is equivalent to this. Okay, this is the equivalent to this, and we have the port. We have the ports. So ports we already mentioned. Now it's all about the functionality. So where is the functionality? Functionality is inside. Functionality is inside. So we have to write here. Here functionality we will write. तो ये functionality लिखने के ही एक से ज्यादा तरीके हैं. For which I said we will see different types of modeling. For example, or for this case, if you want, so we can take different modeling styles. You can write like directly. You can write assign. Directly you can write assign y equal to s negation of s dot I naught, and you can write plus of s of I1. Directly you can write. Now don't think, sir, what is this assign? I don't know. I am not aware of this. आप aware होंगे भी क्यों? You're joining a class, right? I will tell you. I will teach you this. But as of now, what I'm telling is the equivalent thing, like how we are covering. So this is the functionality you did. So this is the one way. ये एक तरीका है. Now what could be the different way? What could be the different way? So another way is nothing but you can write the behavior. You can write the behavior. How is the behavior? You can write whatever is the behavior you are seeing. You can write this as a functionality. So here I believe behavior is if s equal to 0, so y is following I naught, else y is following I1. Agree? No response? Agree or not? Clear, sir?
Yes, sir.
Yes.
Yeah. So let me show you this now in the EDA, and I will just give input, output, and waveform also, so that you will have at least a basic idea कि हम क्या पढ़ने वाले हैं, क्या हमारा ultimate है. Then we'll start one by one. By having this data types and operators, tasks and functions, like that will go. So just a second, let me share the screen. Let me share my screen and I will show you. which is
Sir, we will cover the advanced projects today only. That like you
no,
told
no,
the
no, 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 no. Project will be the very last. Project will not touch. We'll start this one by one. These are kind of a chapters. We have 6 chapters. After completing 6 chapter, we'll start Verilog project.
Okay.
Okay.
So,
So
not
even we
today.
did even we did not started the first chapter. Today we'll start. So the today's session is just about the necessity of Verilog. You should have the idea. One example I am just showing you how the things will happen. Okay, it's something like that. Nothing much. Chaliye, all right. So let me share my laptop screen and let me know if it is visible to you. You can change the screen if I believe you have option. You can see my screen, right? Voice will be from same device, but you can see my screen. Clear? Hai? Yeah, I think you can see. Chaliye, all right. So tool, let me select a tool, and don't worry, I will give you idea for this also, how to use this tool, or if you are not able to access this EDA, then the model same or Vivado, how you can use. Okay, I will come to that also. As of now, it's not required. Just I'm showing you. Chaliye, all right. So you can see here, I will just write here module, and which is mux 2x1. Any name you can give. Can anyone confirm you can see my screen? Whatever I am typing, end module.
Yes, sir.
Yeah, which is correct. Perfect. So module 2:1. Okay. And we already draw the circuit. Okay, we already draw the circuit. And in that we saw what are the inputs and what are the outputs we have. Okay. So here we can take input. We can take input I note, comma I1, comma S, comma output, output, output Y. Don't think why we are writing inputs and outputs, from where it is coming and those things. सर यही लाइब्रेरी है. और देखो किसी ने पूछा भी था, can you see, can that guy see this language and libraries? Understood? And here we are selecting this Verilog, VHDL, Specman. So these libraries nothing but containing the definitions. Okay, so here I opted this Verilog and system Verilog. So it will opt that Verilog. Okay, so now what I can do, I can just write here assign y equal to, or let me write that assign. Okay, assign लिखते हैं. Assign y equal to that negation of s, negation of s, and I note. Everything is same, don't worry. Okay, yeah. So now what is this? S bar and I note, and then after that plus. So this will be same, and here you can see it will become I1, and this negation will not be there. Now what I have to do, I need to drive these value. This is design. This is nothing but design. So I designed that that mux. Now I need to see the behavior. So for that we have Testbench, TB. As of now, don't worry. This is Testbench. These things we have to learn. आज का पर्पज यही है कि हम क्या पढ़ रहे हैं, हमें सीखना क्या है. Okay, don't worry. So it's kind of a design. It's kind of a LED bulb, and Testbench is kind of a LED holder, and it has to drive. So it has to drive inputs, and see or monitor outputs. और सर डिजाइन का काम क्या है? डिजाइन का काम क्या है? टेक इनपुट्स, टेक ड्रिवन inputs and drive outputs. You understood? So it's like that. Understood? I think yes. Chaliye. So here module TB, I'm just writing module TB and module, and let me first run this. No. Okay, so here this is the wire. Yes. I don't want to put that as of now, wire and res. So which is fine. And here I can take mux 2 cross 1. Okay, I'm not. And here I just want to put I note, comma I1, comma S, comma Y. And here we will take a reg of I note, comma I1, comma S. Don't worry about this reg and wire. I will explain you in too much detail. You will understand. Okay, you will understand very well. Don't worry. And those who know, so please have patience. You will learn a lot of things. Believe me. Don't lose the patience. Okay. So here initial, begin, end. So here I can write I naught equal to 0 and I1 equal to 0 and S equal to basically S को 0 करते हैं पहले. S equal to 0. Okay. S equal to 0, I equal to 0, E equal to 0. Okay, all three 0. And now what will do? So after this has 10, then we'll do same thing. Has 10, we'll do this thing. Has 10, we'll do this thing. Okay. Yes. So एक बार इसको ऐसे धीमा और कर लेते हैं. So 0 0 0 0 0 0 1 and 1 0 1 1. That means all combinations basically we are taking 0 1 1 0 and 1 1. Now what I did here, I just designed this mux and I'm giving the inputs. Okay, and how it comes to my like this is a equation. Okay, this is the equation or the Boolean function. How this EDA tool is coming to know? Just because of library. That's why library are important. Okay, let me save this and let me run the code. Just a second. I will show you the waveform also. You will get confidence. Don't worry about these things. Okay. Chali, all right. Let me run now. Yes. So can you see? Can you see the waveform? I think yes. Now what you have to do? So what you have to do and what you need to understand from here? Try to understand. Now you do not need to worry about the complexity because you have the picture now, and the picture you need to verify manually. But rest of the things is computer is doing. So that was the meaning of manual verification and that computer verification. Can you see? Now let me evaluate. Let me evaluate here. You can see the waveform twice. Forget about you can ignore the twice. But can you see the ones? So I naught, I1, S and Y. So how to observe if S is 0? Oh, S is 0 throughout. Sorry. I should make this as high. You didn't tell me, huh? You should tell. So S is high, S is high, S is high, S is high. And then let's see. So what is your expectation here? No response, guys. If S is 0, so Y should follow I naught. If S is 1, Y should follow. Can you see? If S is 0, so Y is equal to I naught. And if S is high, Y is equal to I1. Can you see, guys? No response. Can you observe?
Yes, sir. Yes, sir.
Yeah. But what we did here, first we designed a mux. After that, we gave the inputs and we getting some waveform and we are verifying waveform manually. इसका भी extension है. That also will do. That verification will also happen automatically. But that stage by stage will come. सर फिर अभी क्यों दिखा दिया, हमें क्यों डरा दिया, हमें तो समझ नहीं आया. It's all about you should know, because I don't know from which background you are coming. So you should know these things. Like this we will learn in Verilog. Clear है? चलिए, all right. So anyone have any doubt up to here, you can ask. Then we'll start data type. And the keywords also we'll see.
So what is the difference between drive and driven?
Drive and driven कहाँ पर, जो मैंने comment section में लिखा था?
Yes sir.
हाँ, तो देखिए driven का मतलब हुआ कि कोई आपको ड्राइव कर रहा है, मतलब आपको मिला है. And drive is like it has to drive. Basically driven means input. Understood?
Driven is
So
like
maybe
extension and drive is like we have giving values.
see, driven is nothing but in sense of like receiving, taking. Drive is in sense of output, like giving the value. You can, if you are confusing with this, you can write taking inputs and giving outputs. You can consider like that. Okay, because inputs are driven by testbench and outputs should be driven by the design. You can understand like that. Clear hai?
Okay sir.
Yeah.
Sir, I had one doubt.
Yes, please.
In the third line where you have used assign, so sir, why did we use double ampersand here, sir? Instead
Because
of
so for that purpose only, chapter number 2 is there. Chapter number 2 अभी हमने क्या देखा था? Can you see my second screen? Chapter number 2 is operator.
Yes sir.
An operator में we have logical operator, we have bitwise operator. तो ये वहां पर सीखेंगे. अभी इसमें हमें कुछ सीखना ही नहीं है. This is just for a imagination. Okay, हम कुछ ऐसा करने जा रहे हैं और उसके लिए ही सीखेंगे. You understood? So this answer you will get when I will teach you the second chapter, which is operator. तो ऑपरेटर में मैं आपको 50 क्वेश्चन करके दिखाऊंगा, जिसमें हमारे पास ये वाला एक अलग ऑपरेटर है, ये अलग ऑपरेटर है और ये अलग ऑपरेटर है. These are 3 different operators. चलिए, पहला और दूसरा तो सेम है, आपने रिपीट कर दिया. आंसर इज नो. दिस इज ऑल्सो डिफरेंट. फॉर एग्जाम्पल 110, this value is different, and 110, this value is different. 110 and 110, this is different. ये तीनों डिफरेंट है और तीनों करेक्ट हैं. You understood? So we need to understand what is the syntax, what is the meaning, कहां पर कौन सा यूज होगा. reduction operator क्या है, and logical क्या है, bitwise क्या है, you will see. Okay, and sometimes you will see the like greater than, sometimes you will see greater than. So that you will learn in the second chapter. So you will get your answer in the second chapter. It's all about syntax and those things. Anyone have any doubt?
Why we need to use that initial begin, sir?
Initial begin you will learn in chapter 3. Because when I mentioned like process, if you can see my second screen, so these are the process, and where I mentioned initial and always. So as of now, you should not know, or you should not have that motivation also to understand what is the initial, what is the begin, and always. Forget about that. It's all about something like that will do. एक दिन हम ऐसे ही वेंडिंग मशीन को डिजाइन करेंगे, ऐसे ही वेंडिंग मशीन को टेस्ट बेंच से ड्राइव करेंगे और वेवफॉर्म देखेंगे. But how you will get that level when we'll finish these 6 chapters. Okay, so first we'll target this line number 8 and 9, which is nothing but the data type. And उससे पहले शायद मैं वो भी कवर करूंगा like keywords, which is module, end module, inputs and output, and port list, and those things also. So we'll cover. Clear everyone? Anyone have any doubt? So maybe after 4 or 5 sessions you will get idea, and I will try to give you homework, and you will get a very good hands-on. So anyone have any doubt up to here, you can ask, else I will start either keywords or data type. Data type I will start. Tell me if anyone have any doubt. So we'll start our first chapter, that is very long.
Sir, for how much more time this session will continue?
Will take at least 1.5 to 2 weeks. Oh, today you are asking?
Yes, sir.
Today I will have a total 2-hour session. I don't know the time, but total from the start 7 to 9 we targeted.
Okay, sir.
Yeah, 7 to 9. Okay, so let me start the data type. Shall we start, or you want break or something? Generally I take 2-hour session without break.
No, continue.
Continue now. Fine, thanks. Okay, so last chance. Anyone have any doubt? You got a sense, right? Chali, all right. Now can you see my second screen, please? I am just stopping this screen. 1 second. Yes, zoom. Oh, where's... Oh, I believe you are seeing my this screen, right? Where I am writing. Can you see? Can you see this notepad?
No, sir.
No, sir.
Huh? Why? Just
Yes,
second,
sir.
let me share. You can see, right? Sharing
Yes,
is
sir.
going on. Can you switch to the another screen, right? Where I just mentioned that chapter number 1, 2, 3. Okay. Where I mentioned the chapter number 1, 2, 3. Can you see this?
Yes.
Chapter
Yes.
number 1, data type, operators. Okay. Okay. And this example, right? So now let me start. Now try to understand what are the data types. What are? So basically, what is a data type? Can someone tell me?
It is a container.
Yeah. Can you repeat, please?
It is a container.
The word what you used, which is absolutely correct. I think ये मेरा ही repeat किया है आपने. But something additionally I want. Has anyone?
It refers to what type of data we are like int string.
Yeah, correct. The sense is correct.
Which
Okay.
holds the values.
Okay, which is also right. Okay, let me tell you. Try to understand first why data type is required, and then we'll see what types of data. देखिए हर एक टॉपिक के लिए मेरे दो ही चीज इंपॉर्टेंट होती है, why and what. मतलब वो टॉपिक क्यों और वो क्या है. So first we'll see why data types, then we'll see what. So try to understand whenever we are planning to design a device or a circuit. Okay, whenever we are planning to design, so circuit may get some input and may give some outputs. So which is nothing but some form of input it will take and some form of output it will give. और वो input output का form voltage हो सकता है, कुछ भी हो सकता है. And we can say that data. Basically data is taking and data is giving. So the type of data is matter. For example, if I will talk about in mechanical thing, so let's say we have some 1 second. Yes. Let me just talk about. This is a nothing but a liquid. So can you tell me what is this liquid? Can you tell me what is this liquid?
Okay.
And glass. So glass is not that. Glass is I'm talking about that cup or that holder kind of thing, that container, that glass I'm talking. Okay, yeah. Or let me just write the bottle here instead of glass, else you will confuse. So some bottle or some mug here. Okay, let me just write like mug here. Yeah. So can someone tell me what is this liquid here? So liquid is actually category. Liquid is a category. And what is this mug? This mug is a
Container.
so bottle. What is a bottle? So bottle is a container which may contain liquid. So ultimately, what is the liquid here? So liquid is a type. So screen others can see. 1 second, let me reshare. Just a second, sorry. आपको पहले बताना था ना. Stop sharing. I stop sharing. और हमारा अपना दूसरा स्क्रीन देख रहे थे. 1 second.
विजिबल है सर?
नहीं, आप EDA देख रहे हैं.
ठीक है.
I will share only one screen at a time from now. Don't worry. Yeah. Can you see?
Yes, sir.
Can you see now?
Yes, sir.
Can you see?
Now it is fine.
Yes, sir.
हाँ, आपको change करनी थी screen. Don't worry. Sorry. So what is liquid here and what is this mug? So here what happens? That mug and bottle and glass and that bowl. So these are the container which may contain a liquid type. So this liquid type is nothing but a data type, which is telling like what type of data a container can contain. A container can contain what type of data. Similarly, the another example could be a gas. Sorry. So another example could be a gas. And here I can write like cylinder. Okay, cylinder and some extra. Okay. Now Now try to understand. What is this liquid and gas? So these are the data types. But it different data types हैं. Okay. What a container can contain is nothing but a data type. What type of data can contain? So if we'll talk about in Verilog, why we have multiple types of data? Why we have multiple types of data type? So try to understand. We have mainly two category. We have mainly two category in data type. We have mainly two category in data type. One is that wire and another one is res. So don't you think in a mechanical system also we have main two category? Answer is yes. Answer is yes. If you will see, one is for bypass and one is for hold. One is for bypass, one is for hold. What mean by this? If you will see on the petrol pump, you have two equipment. One is pipe and one is that tank. So can someone tell me, a pipe and tank both can contain petrol? Answer is yes. No response. No
Yes, sir.
response. I think yes.
Yes, sir.
But they are, or they belongs to a different type. Pipe can only bypass the petrol but can't hold. Lekin tank can hold. Tank can hold. Another example. Electric wire. Electric wire can bypass the electricity, but electric battery, जो बैटरी है ना सर, सेल होता है ना, जो सेल, सो बैटरी कैन होल्ड द चार्ज. समझ रहे हैं ना? देखिए, वायर भी चार्ज को कंटेन करता है, बैटरी भी चार्ज को कंटेन करती है, लेकिन वायर में अपनी कैपेबिलिटी नहीं, अपने अंदर रख नहीं सकता, वो केवल पास कर सकता है. लेकिन बैटरी, इन्वर्टर के साथ बैटरी होती है ना, स्टोर करके रखती है ना. गेटिंग माय पॉइंट? Similarly, you have a gas cylinder. You have gas cylinder and you have gas pipe. सर, पाइप से गैस निकलती है, सिलेंडर में गैस होती है. You understood? No response? So I think I put the sufficient example. So what is a data type? Data type is nothing but what type of data a container can contain. And they have mainly two types. One is to bypass and one is to hold. So if we will talk about Verilog, so Verilog also have two types of data type, two category basically. Two category. One is that wire and one is res. So as name suggests itself, or by name you can get an idea, this wire is used for the bypass purpose and this res is used for the storage purpose. You understood, guys? No response?
Yes, sir.
Yeah. So that we'll see in Verilog how we can use these things. Clear? Eh?
Yes, sir.
Yeah. So now let me just start about this syntax. So, and what are the data types we have? So one is that wire and next one is that res. So just a second. Yeah, chaliye, all right. So actually, in terms of name, I should write the category, exact category is, I should write. So these are the net. Net is the category and register. Register. Okay. And under net, we have this wire. So wire is the keyword and wire is the actual data type. And under register, we have reg, we have integer, we have real, we have time, and we have a string. So I will pick one by one and I will show you how these are different from each other through coding. Okay, but you should keep in mind these are just for bypass purpose, and these registers are to hold. They can hold or they can store the data. Okay, so reg is of 1 bit wide. Reg is of 1 bit wide, and integer is nothing but it's a vector. It's a vector. It's a kind of a scalar or the group of reg only. Okay, and what about this real and time and string? So we'll start one by one. Okay, just a second. Let me start the specification. Just a second. Yeah. So reg is nothing but of 1 bit. Okay, 1 bit, and which is equivalent to a 1 flop. But what about integer? Integer is of 32 bit. Okay, 32 bit. For example, reg a. So here a is a variable which is of reg type and it can contain 1 bit value. So a equal to 1 tick b 1 is valid. But if it is of integer type, for example, if I am writing integer I, okay, integer I, which means I can contain 32 bits. I can contain 32 bits. So I equal to 32 tick b 0000824 something like that. 32 bits number it can store. Okay, but when it comes to time, so can anyone guess the size of time? So the size of this time is nothing but 64 bit.
64 bit
64 bit.
and real also.
And what is
Real
the special thing in this time? So this is nothing but a unsigned number. Why unsigned? Because time cannot be a unsigned. Okay, so don't worry, I will show you these all things with respect to code. You will really enjoy. But as of now, I'm just giving you a first level idea. So tomorrow we'll see these data types in detail, and tomorrow we'll finish. Okay. And what about this real? What about this real? So
64 bit.
yeah, but it can store floating point value. Okay, floating point values. And what about this string? Can anyone tell me? String is supported in the Verilog or not? Can anyone tell me?
एक्चुअल में स्ट्रिंग होता नहीं है बट
Absolutely correct answer.
कॉन्केटनेशन से हम लोग काम चला
Yeah, so he is absolutely correct. So string is not actually data type. String is not a data type. I should not write this with the blue color, but you can achieve this. What mean by you can achieve this? string is not a data type supported in the Verilog, although you can store a string. You can store a string. How you can store a string? You can store a string in reg itself. So you can have a vector. You can have a vectors of reg, like reg of 8 and then like let's say 10, 1. So what is this? What is this? It can store 8 alphabets. Am I right? 8, no, 10. 10 alphabets. 10 alphabets it can store, like if you are writing S. So you can write inverted comma, you can write something like hello. You can write something like that. So actually string is not a data type. It's not like you can write simply, अगर आप ऐसे लिखेंगे तो वो illegal है. String S is a wrong example and this is the correct example. String S equal to inverted comma में hello लिखना ये unsupported है in Verilog. Clear है guys? So don't worry, I will show you in detail about the size. I will print these value. I will show you the type. I will show you the size of each, and I will show you how to differentiate a signed and unsigned, like integer. Then what are the scalars? What are the vectors? And those things we'll understand. So anyone have any doubt in this? You can ask. Else, I believe tomorrow we'll finish our data types. This chapter we'll see in detail. So anyone have any doubt in this? You can ask.
Sir, in the integer line 32-bit, for the example, you wrote 32 bit 32 binary 0084. So, sir, how can we write 84? Instead, we should write 0 in the form of 0 and 1 only.
Sorry, I can say this is D. 32 D. You are right. You are right. Sorry. I believe the number could be of मतलब binary में जितना maximum 32 bits number available है. In that sense, I wrote. But yeah, that was the mistake. Yeah, you are right. When I said B, so it should be 10 only. You are right, huh? Yeah, anyone have any doubt? So today we learn, I think, the basic idea of digital, okay, the kind of a brush up. Then after that, I gave you one counter question, which is fabulous if you'll do this. So those who said 4, I want circuit, okay. Then after that, you understand basically what is the main thing, the precious thing in the EC branch. Then we just started with the Verilog requirements, the necessity of Verilog. Then we just discussed about the roadmap or the table, what we will cover. And after that, at last, we'll see the project. Then after that, I just proposed one example like that will target. And then we started the data types. After seeing one example, we started the data types, and you learn what is the basically data type, what type of data types we have, and one line about each data types. But in detail, you will see, I will propose at least 5 example with respect to each data types, and then you will understand. So anyone have any doubt, you can ask. Else you may leave the call. We'll see tomorrow session. Anyone have any doubt, you can ask.
सर आपने जो क्वेश्चन दिया है 38x+4,
हाँ जी,
उसके अंदर सर क्या ये गिवन है कि x कितनी बिट्स का है?
x तो आप 4 बिट का ही ले लो.
4 बिट का. और सर क्या ये अप्रोच
1 मिनट जो ये मैटर करता है वो प्लस में जो नंबर है ना उससे बस बड़ा होना चाहिए. हाँ 4 है ना, हाँ ठीक है, यू कैन टेक 4 बिट.
सर तो क्या हम 38x को 32x + 4x + 2x में डिवाइड करके इसको कर सकते हैं?
आई डोंट नो, यही तो आपको करना है ना, ये तो होमवर्क क्वेश्चन है ना.
ओके सर.
मल्टीपल वेज हो सकते हैं, मतलब बहुत सारे तरीके हो सकते हैं. और व्हाट आई वांट, अगर आप 38 के लिए कर लेते हैं तो आप कुछ उसको और अलग ब्रेक डाउन करें. लेट्स से 71x, मतलब उसे 2 का मल्टीपल भी हटाएं स्टेप बाय स्टेप. इट्स ऑल अबाउट लाइक ब्रशअपिंग थिंग्स. ऐसा नहीं है कि ये क्वेश्चन कोई यूपीएससी में पूछेगा या कोई जरूरी पूछेगा ही, बट अगर आपने ऐसा किए तो आपकी अप्रोच अच्छी हो जाएगी, तो शायद पूछे हुए क्वेश्चन भी आप कर पाओगे.
Okay, sir.
Okay, and one more question I have. Let's say y equal to one second, z equal to how to put x plus y bar. So you need to prove one more question. You can write. You need to prove one circuit I have is z equal to x plus y bar, and this is the universal circuit. This is the universal circuit. You can put. You can try. You can try if you want. It's a optional homework. Z equal to x plus y bar is a proof. This is the universal circuit. I believe you know about universal. Anji, anyone have any doubt?
Sir,
सर
will you
आपने
use
100x plus
Anji, 100x plus
100x plus 4 करके लिखा था ना ऊपर
100x plus 4 कहाँ लिखा था? हाँ ये लिखा था, बट ये
सर
डेसिमल
उसका
में
बेस
था. ये डेसिमल में है. 64 into 100 6400 हो रहा है, which is in the decimal, right? तो ये सब कुछ डेसिमल में है. इसके नीचे फिर बाइनरी इक्विवेलेंट है. So what's
ओके
your doubt here? Tell me.
बेस कौन सा है सर?
ये 6 किस बेस में आता है? ये सब तो डेसिमल है ना.
हाँ,
r equal to 10.
समझ आ रहा है.
r equal to 10. 6 तो नहीं आएगा ना बाइनरी में, और इतना ऑड बेस हम लेंगे नहीं कि बेस 6 या बेस 7. नो डाउट. ओ सॉरी, नो प्रॉब्लम. क्लियर है? अभी क्लियर है?
sir, will you
हाँ
use
सर.
EDA tool or Vivado?
See, I will be using EDA tool, but try to understand it's all about one time setup. एक बार सेटअप के बाद तो फाइल ही है और कोड ही लिखना है, करेक्ट? So you can make your own setup, don't worry.
Okay, sir.
But I will use that only. Okay, fine then. Thank you everyone. Thank you everyone.